Hi, this is Mr. Miller, and in this video, I want to go over the solutions to the practice mastery quiz so that when it comes time, you're totally ready for the real quiz. So the first problem here, we're given a function, a rational function, and its equation is right here. And we're also given a graph of it. It says the graph of f of x equals 3x minus 6 over x minus 4 is shown on the right. Part A says use interval notation to describe the domain of this function. So this is all the values of x where the function is defined. And pretty much that's everywhere except where the vertical asymptote occurs. And in this function, that occurs at 4. All right, so we're going to say the domain is from minus infinity to 4 union 4 to infinity. It is everything from negative infinity up to the asymptote, not including where the asymptote is, and everything after that. So pretty much this notation leaves out the value x equals 4 and includes everything else. For part B, we want to describe the range of the function. The range of the function includes everything except the value where the horizontal asymptote is. In this case, that's equal to 3. We can see that because the ratio of the x terms is 3, and also we can see that in the graph here. So we would write this as negative infinity to 3. That's all of these y values right here, and union 3 to infinity. That's everything above the asymptote right there. The only thing it doesn't include is y equals 3. All right, so now it asks for an equation for the vertical asymptote. So this is a vertical line, and vertical lines have the form x equals something. So this is going to be x equals 4. That's this value right here. And the horizontal asymptote, well, equation for a horizontal line is y equals something. In this case, y equals 3. All right, it says use limit notation to describe the end behavior of this function. Well, that's the limit as x goes to negative infinity of the function. And we'll write what that equals in a moment. And on the other end is the limit as x goes to positive infinity of the function. On the left side, as x goes to negative infinity here, we see the y value is approaching the horizontal asymptote. It's approaching 3. And on this other side, as x goes to positive infinity, the function is approaching the horizontal asymptote on this side as well, and so the limit is 3. Okay. F says use limit notation to describe the behavior of this function on the left and right sides of the vertical asymptote. So that's about this point right here. So we're going to describe the behavior on the left of the asymptote at 4. So that's what that little minus means, from the left of f of x. And we're going to describe the behavior as x approaches from the right. Okay, from the left, as x gets closer and closer to on this side to the asymptote, our function is going to negative infinity. And as we approach positive 4 from the right, our function is approaching positive infinity. Okay, problem number 2. This is a problem we've done a couple of weeks ago where we're developing a graph of a rational function here. So they want to know where the asymptotes are, the intercepts, and some points that belong to it. Then we're going to sketch the graph of it. So the vertical asymptote occurs at the value of x where the denominator is equal to 0. So in this case, that's going to happen at x equals 3. All right, so at x equals 3, I'm going to draw a dashed vertical line. Okay, the horizontal asymptote, well, that's the value the function approaches when x is large. So when x is large, either positive or negative, this function is about negative 2x over x, which is negative 2. So the horizontal asymptote is y equals negative 2. So that would be down here. Okay, the y-intercept is the point where the graph crosses the y-axis, and it's also the point that has x equal to 0. So if we put 0 into the function, the numerator is 4 and the denominator is negative 3, so that's negative 4/3. Now finally, the x-intercept occurs when the numerator is equal to 0. And I see that's going to happen when x equals 2. So now x equals 2, we get negative 4 plus 4, which is 0. So 2, 0. Okay. So we're going to find 4 additional points that belong to the graph. So we've learned to look to the right of the vertical asymptote and to the left. So I'm going to put in 4 and 5. I'm also going to put in 2 and 1. When x equals 4, the numerator is negative 8 and the denominator is, when x equals 4, the numerator is negative 4 and the denominator is 1. So we get negative 4. So 4, negative 4 is right here. And when x is 5, the numerator is negative 6 over 2, which is negative 3. So that point is right there. When x is 2, we've already figured out that the function is 0. When x is 1, we get 2 over negative 2, which is negative 1. And so that looks like that. And I'm going to do my best I can to sketch in this function. It goes from negative infinity through those points and approaches the horizontal asymptote. And it's going to come down from infinity like this, go through those 2 points, and approach the asymptote that way. Okay, your sketch on paper is probably a lot better than mine, but that's the basic graph of this. All right, down here it says write equations for vertical and horizontal asymptotes of the rational function. So, okay, the vertical asymptote occurs at the value of x that makes the denominator 0. So this time, it's a little bit harder for me to see. So I'm just going to set the denominator equal to 0. If I subtract 6 on both sides, I get 8x equals negative 6, or x is negative 6 over 8. And if I reduce that, I get negative 3/4. Okay. So that's the vertical asymptote. It can occur at fractions. Right, the horizontal asymptote, well, in this case, this is one of those cases where the numerator is a constant and the denominator is a linear function. We learned that the horizontal asymptote is just 0. Another way to look at this is the numerator is 0x minus 7 divided by 8x plus 6. And if I think of it this way, the ratio of the x terms is 0, which gives us the same thing. All right. We want to write an equation for the rational function given below. So this one has a non-zero horizontal asymptote, and we're going to use this pattern. F of x equals a x minus p all divided by x minus q. In this case, A is the horizontal asymptote, which looks like it's at 4. P is the location of the 0, which is at 1. It's labeled here. And Q is the location of the vertical asymptote, which is at 6. So actually we have everything we need. We can just put this in, and f of x is equal to 4 x minus 1 divided by x minus 6. Okay, done. That makes sense. Vertical asymptote at 6, The numerator is 0 at 1. The ratio of the x terms is 4 over 1, which is 4. And all right, that totally checks. Okay, on this one, all right, so we're going to write an equation for a function, but this time it has a 0 horizontal asymptote. We have to use kind of the other pattern. F of x equals a over x minus q. Okay, so in this case, f of x is equal to a, I don't know what that is, over x minus a negative 4 is x plus 4. Okay, so we have everything. We just need to figure out a, and that's where we're going to use this point. We're going to put negative 3 in for the function and 2 in for x. Oops. So that would be 2 plus 4 down here. So we get negative 3 equals a divided by 6. If I multiply both sides by 6, I get a equals negative 18. And we're going to put that in right here. So we get f of x equals negative 18 over x plus 4. All right, we have just 2 problems left. This problem, we're given a graph, and we just want to know what are the values of x where the function's greater than 0. So we want to know where is it above the x-axis. Well, this whole piece is above the x-axis, so from negative infinity up to this asymptote, which is at negative 4, the function is above the x-axis, so from minus infinity to 4. And then we see it crosses the x-axis right here at 3. So from there to infinity, sorry, this should have been a negative 4. From there to infinity, it's positive also. So we got from negative infinity to negative 4, union, so it's a union symbol, 3 to infinity. Okay, this piece right here, and this piece right there. Okay, last problem. This time we don't have a graph, we're just going to use a sign chart. Okay, so, well, to create a sign chart, we're going to draw x-axis here. And we're going to label the points where the zeros and the vertical asymptote occur. So the vertical asymptote here occurs at x equals negative 2. I'm just going to put a little note that that's a vertical asymptote. The 0 is at 4, because if I set 3x minus 12 equal to 0, we get 3x equals 12, or x equals 4. All right, and that's a 0. So I'm going to keep careful to distinguish whether these are points where the function was undefined or where it was 0. So now I got to pick points and test the function. So I'm going to put in like negative 10. So 3 times negative 10 minus 12 over negative 10 plus 2. Well, this would be a negative number divided by a negative. That equals a positive, right? 0 is a number in here. If I put in 0, I have 3 times 0 minus 12 over 0 plus 2. That's going to be a negative over a positive, which is negative. And if I put a point in over here, like say 6, 3 times 6 minus 12 over 6 plus 2, it's a positive over a positive, so that's a positive. Okay, so that's our sign graph. We know everywhere where the function is positive and negative. Now we can answer a question. It says, where is it less than or equal to 0? Well, it's negative in this middle interval, and it's actually equal to 0 here at 4. So we're going to say from negative 2, curve parentheses, because it doesn't equal anything at the vertical asymptote, to 4, with a square bracket. All right, that's a lot of stuff, but go over this carefully and ask questions in class, and you'll do fine.